Continuing our video series on exponents, we're going to take a look at I can find the power of a quotient. We're going to jump right into the examples this time because all the rules that we've established in previous videos apply here. This time we have 3x squared divided by 4y to the fourth, and that's all to the second power. Now there's two ways to approach these problems. We can either simplify what's in the parentheses and then take care of the outside exponent, or vice versa, we can take care of the outside exponent first and then simplify. For the first two, we're going to do that latter approach, and we're going to take care of that outside exponent first and then simplify as best we can. So here we have this entire quantity, 3x squared divided by 4y to the fourth, and it's all to the second power. Now we remember from previous videos that when we have a whole term, a whole expression to a power, we're going to take that power to each and every piece of that expression. So when we say 3x squared over 4y to the fourth to the second power, we mean take every single piece to the second power. So let's see what that looks like. We'll take 3 squared, and we'll take x squared squared. That's in the numerator. In the denominator, we'll take 4 and we'll square it, and then we'll take y to the fourth and we'll square it. From here we can simplify a little more. We know what 3 squared is. Of course, that's 9. And then x squared squared, we're going to have a power to a power. And so in this case, according to our rules, we should multiply those exponents together to get x to the fourth. That's the numerator. In the denominator, we have 4 squared, which we know is 16. And then we have y to the fourth to the second power. Exponent to an exponent means multiply. So y to the 8th power. At this stage, if there was anything we could simplify, we would. I don't think we have anything in this case, so we'll move on to number 2. We have 7x squared y cubed over 8xy squared, and that's all to the third power. We're going to take every single thing inside the parentheses. This is a single term in here. So we're going to take every single thing to the third power, and then we'll simplify from there. 7 to the third power, x squared to the third power, y cubed to the third power. That's all divided by 8 to the third power, x to the third power, and then y squared to the third power. Take care of the numerator first. 7 cubed is 343. X squared cubed, power to a power, multiply, x to the 6th. Y cubed cubed, multiply the exponents again to give us y to the 9th. And then the denominator, we have 8 cubed, which of course is 512. We have x cubed. And then we have y squared cubed. Exponent to exponent means multiply, y to the 6th. We'll simplify a bit more because we still have some x's in both the numerator and the denominator. And so our final step will be to actually do this division. According to our rules, when we divide, we subtract the exponents. The numbers can't be simplified in any way, so we'll keep those exactly the same. X to the 6th divided by x to the 3rd. We're dividing, they have the same base, and so we'll subtract the exponents. 6 minus 3 gives us x to the 3rd. The same thing's true about the y's. They have the same base, and so when we're dividing them, we subtract the exponents. 9 minus 6 gives us y to the 3rd. That's our answer for number 2. Now I mentioned a bit ago there's two approaches. We can handle the exponent on the outside first, or we can simplify the inside and then handle the exponent. For number 3, we'll take that second approach. We're going to simplify the inside first, and then we'll handle this exponent of 4 in just a bit. So let's take a look at just the inside first. 12 divided by 6, of course, is 2. M to the 8th and m have the same base. And since they're being divided, we'll subtract their exponents. M is, of course, just m to the 1st. If there's no exponent, we assume it's 1. M to the 8th divided by m to the 1st, 8 minus 1, gives us m to the 7th. And then finally, n cubed divided by n squared, they have the same base, and so we'll subtract their exponents. 3 minus 2 gives us n to the 1st. Now don't forget that this is all to the 4th power. So we'll handle that now. If an entire expression is to the fourth power, we're going to take each and every component to the fourth power. So we'll take 2 to the fourth power, we'll take m to the 7th to the fourth power, and we'll take n to the 1st to the fourth power. 2 to the 4th is 16. And then we have some exponents to exponents. So m to the 7th to the 4th, exponent to exponent means multiply. So m, 7 times 4 is m to the 28th. And finally, n to the 1st to the 4th, exponent to exponent, multiply those together to get n to the 1 times 4, which is n to the 4th. And that's our answer for number 3.